linear differential equation and we have to find out the solution for that. So it is dy by dx into hyperbolic cos x equal to 2 times hyperbolic cos square x hyperbolic sin x minus y hyperbolic sin x. Now the thing is how to solve this differential equation. So guys, to get the solution, I will first readjust the terms. So for that, I will send this hyperbolic cos x on right hand side. So since it is multiplying here, it will divide to these two terms on right hand side. So here I'll say therefore dy by dx equal to, so this will become 2 times hyperbolic cos x into hyperbolic sin x, because when we'll divide this term with hyperbolic cos x, one hyperbolic cos x will be cancelled, minus y hyperbolic sin x upon hyperbolic cos x. Now I'll take this term on left hand side, so we will get dy by dx plus hyperbolic sin x upon hyperbolic cos x into y is equal to 2 times hyperbolic cos x into hyperbolic sin x. And guys, here this equation got converted into linear differential equation where y is the dependent variable and dy by dx is the derivative of the dependent variable, and both are having degree as 1. So such equation is called as linear differential equation. So to solve the linear differential equation, first of all we need to find out the integrating factor for that. So here I'll say therefore comparing with dy by dx plus py equal to q, we will get value of p equal to hyperbolic sin x upon hyperbolic cos x, and the value of q is the right hand side, that is 2 times hyperbolic cos x into hyperbolic sin x. Now guys, let's find out the integrating factor. So here I'll say therefore the integrating factor is given by the formula e raised to integration of p dx. So e raised to integration of hyperbolic sin x upon hyperbolic cos x dx. Now guys, what is the integration of this hyperbolic sin x upon hyperbolic cos x? So here I am going to use the property of integration which says integration of f dash of x upon f of x dx is equal to log of f of x. So guys, here if you will see, then f of x is hyperbolic cos x and its derivative is hyperbolic sin x. So it is matching with this property. So here I can say that it is equal to e raised to log of hyperbolic cos x. So by the formula of log, here we will get hyperbolic cos x. So it means the integrating factor is hyperbolic cos x. Now let's find out the solution. So I'll say therefore its solution is given by so the formula to get the solution is y into integrating factor equals to integration of q into integrating factor dx plus c. So y as it is, the integrating factor is hyperbolic cos x equal to, on the right hand side we'll get integration of q. So what is value of q? So here let's see, the q is 2 times hyperbolic cos x into hyperbolic sin x. So 2 times hyperbolic cos x into hyperbolic sin x. Next, into integrating factor which is hyperbolic cos x dx plus c. So now to get the solution we have to evaluate this integration. So the question is how to evaluate this integration. So guys, it's simple. What I'll do is I'll put this hyperbolic cos x as t, because we know that the derivative of hyperbolic cos x is hyperbolic sin x dx. So we can get hyperbolic sin x dx as dt. So here I'll say put hyperbolic cos x equal to t. So therefore it will give us hyperbolic sin x dx equal to dt. So therefore we will get y into hyperbolic cos x equal to integration of, so this will become 2 and this is t and t, so t square, so 2t square dt plus c. So here 2 outside and the integration of t square is t cube upon 3 plus c y hyperbolic cos x. So therefore substituting t as hyperbolic cos x, so we'll get y into hyperbolic cos x is equal to 2 upon 3 hyperbolic cos cube x plus c. So guys, this is the solution of the given differential equation. So here we got the solution of differential equation by using the method of linear differential equation. Thank you very much.